Welcome back to Operating Systems Crashcast. I'm Victor, and with me as always is the brilliant Sheila. Today, we're exploring some classic synchronization problems that have been challenging computer scientists for decades.
That's right, Victor. These problems might be old, but they're still super relevant in modern operating systems and concurrent programming. We'll cover three main problems today: the bounded buffer problem, the readers-writers problem, and the dining philosophers problem.
Let's start with the bounded buffer problem, also known as the producer-consumer problem. Picture a factory where items are being made and stored in a warehouse with limited space. Some workers are producing items, while others are taking them away. The challenge? Making sure producers don't overfill the warehouse and consumers don't try to take items when it's empty.
Great analogy, Victor. In computer terms, we're dealing with a fixed-size buffer shared by producer and consumer processes. The key here is ensuring that producers don't add data to a full buffer and that consumers don't remove data from an empty one.
Exactly. To solve this, we typically use things called semaphores. Think of them as traffic lights that control access to the buffer. We use one to track empty slots, another for full slots, and a special lock to ensure only one process updates the buffer at a time.
Nice explanation, Victor. This problem comes up in real-world scenarios like managing print jobs or handling network data. Now, let's move on to the readers-writers problem. This one's a bit trickier.
Indeed it is, Sheila. The readers-writers problem is like managing access to a popular library book. Many people can read the book at the same time, but when someone wants to update or write in the book, they need it all to themselves.
That's a great way to put it, Victor. In computing, we have a shared database that multiple processes can read simultaneously. But when a process needs to write to the database, it needs exclusive access. The tricky part is making sure readers aren't kept waiting unless a writer is already using the database.
Right. And there are different versions of this problem that give priority to either readers or writers to prevent them from being left out indefinitely. It's usually solved using those semaphores we mentioned earlier or similar tools.
This problem is particularly important in database systems and file systems where we need to balance reading and writing efficiently. Now, shall we tackle our final problem, the famous dining philosophers problem?
Ah, the dining philosophers problem, a true classic. Imagine 5 philosophers sitting around a circular table. Each has a plate of spaghetti and a fork between each pair of neighbors. To eat, a philosopher needs 2 forks, but there aren't enough for everyone to eat at the same time.
It's a quirky scenario, but it represents a fundamental challenge in resource allocation. Each philosopher switches between thinking and eating, needing both forks to eat. The problem is designing a system that lets the philosophers eat without causing a deadlock. A situation where everyone's holding one fork and endlessly waiting for another.
Exactly, Sheila. This problem shows the challenges of avoiding deadlock and starvation in a system with limited resources. Solutions often involve introducing a waiter to oversee the philosophers, using a specific order for picking up forks, or limiting how many philosophers can sit at the table at once.
These solutions have real-world applications in how operating systems allocate resources and in designing protocols for shared resource access in distributed systems. It's amazing how these abstract problems relate to practical challenges in modern computing.
Absolutely, Sheila. As we wrap up, let's recap the key points. We've discussed 3 classic synchronization problems: the bounded buffer problem, dealing with producer-consumer scenarios; the readers-writers problem, balancing multiple readers with exclusive writers; and the dining philosophers problem, illustrating resource allocation challenges.
These problems aren't just theoretical exercises. They represent real challenges in operating systems and concurrent programming. Understanding them and their solutions is crucial for designing efficient and deadlock-free systems. And hey, if you're preparing for an interview, you might be asked to describe these problems, explain their challenges, or even outline potential solutions.
Great summary, Sheila. That's all we have time for today. Thanks for tuning in to Operating Systems Crashcast. Until next time, Keep your processes in sync and your resources well managed.